Okay guys, welcome to the third and final lesson of this unit. We are nearly done. I just got one more lesson and then we'll call it good. Okay, so far in this unit on stoichiometry, we have talked about the idea of balancing chemical equations. We've talked about what a mole is and how that number is useful in chemistry. We've talked about some dimensional analysis in converting different units between each other. And now we are left with the final topic for this unit, which is the topic of limiting reagents. I'm not sure what word I used in the first lesson. Reagents is the same thing as reactants. So if I said reactants in the first one, reagents is the same thing. It's just the chemicals on the left side of the chemical equation that form the products. Reagents, reactants, same thing. Okay. So this topic is going to kind of pull on the different topics we've talked about already in this unit. So let's go ahead and jump right into it. I'm going to throw up a equation here. Let's do a combustion reaction. Okay, so we've got methane and oxygen forms CO2 and water. I'm going to go ahead and balance it real quick. Got to squeeze it in there. Okay, just making sure it's balanced. C's are good. I've got 4 H's, 4 oxygens, and then 2 and 2. Okay, so this should be balanced. So here's a chemical reaction that we may want to deal with. Now, we know that this equation is balanced as it is. So if I had 1 molecule of methane and 2 molecules of O2, I could react them together and make 1 molecule of CO2 and 2 molecules of water, right? Similarly, if I had 1 mole of methane molecules and 2 moles of oxygen molecules, then I could get 1 mole of CO2 and 2 moles of H2O out of that reaction, right? Well, that's good to know, but the thing is, when we do chemical reactions, we talked about this in the last lesson, we don't really think about it in terms of a small number of molecules or even moles really per se. We think about things in grams more when we're weighing something out. And then the other thing on top of that is, if I were to weigh out a certain amount of methane and a certain amount of oxygen, odds are that I'm not going to create or weigh out the exact ratio of reagents to make this reaction happen perfectly. I'm probably going to have a little extra of one or a little extra of the other, and I'm going to have some leftovers before I do that. And so because of that, what we're going to do is we're going to talk about this idea of a limiting reagent and figure out how to calculate that for the purposes of doing this in the lab. Okay, so we're going to come back to this specific reaction. But before we do, I kind of want to talk about this concept in something that's a little more, in a way that's a little more familiar. Okay, so the idea of limiting reagents is just, it takes a certain amount of parts to put together, and if I'm missing one of the component parts, I'm not going to be able to make my product. Okay, so let's think of this in terms of building something, right? If I don't know, let's say I want to build a wagon, and I need 4 wheels. I'll abbreviate wheels as WH. 4 wheels for my wagon, and then 1 body part, right? That's like the bucket part with the handle. 1 body part is going to yield 1 wagon, right? And so this is the ratio of parts that I need to make a wagon. Okay, I know we were talking about chemistry a second ago, but this kind of idea is going to help us figure out how to solve these problems. Okay, so let's just say, if I had 8 wheels but only 1 body, and I want to ask, okay, well, how many wagons can I make with these parts that I have? Well, we can see pretty quickly that, well, if I only have 1 body, I can only make 1 wagon, right? The body here is what we call the limiting reagent, so to speak. in this example, right? I'll be able to use one body, and I'll be able to use 4 of the wheels to make my wagon, but I'm going to have 4 left over, right? So we might say that I have 4 wheels in excess. Okay. In a similar situation, what if I had 6 wheels? Let me do something. Yeah, if I had 2 bodies, but only 6 wheels. Yeah, let's do that example. Right? Again, I can only make 1 wagon because I'm limited in the number of wheels that I have, right? I can't make 2 wagons with only 6 wheels. And so this now, in this case, becomes the limiting reagent. Right? My wheels are my limiting reagent, and I would have an excess of 1 body, right? I would use 1 to make a wagon, but then I would have 1 left over, okay? So that's kind of rudimentary, and a lot of us can do that in our head. This gets a little more challenging when the numbers are not so easy, okay? What if I had this situation where I have 63 wheels and I have 21 bodies for a wagon? Now this is possible to do in our heads, and it's probably not terribly difficult, but we want to figure out a process to help us figure out this type of problem of which one of these is the limiting reactant. Am I short on wheels in this case, or am I short on bodies in this case? We want to figure out a process in order to do that. And so what we're actually going to do is we're going to use something we learned in lesson 2, which is the idea of using a conversion factor. Okay, and so really what we're going to do in this example is we need to figure out the ratio of wheels to bodies that we have. Okay, and really what that is that's just going to come straight from our reaction, so to speak, where my ratio, in order to make a wagon, my ratio is 4 wheels to 1 body. Okay, that's the ratio of reagents that will make my product. Okay, and this conversion factor is going to help me do that. And so if I'm trying to figure out which one of these is the limiting reactant, I'm going to use kind of a trial and error method, where what I want to do is I'm going to take both of these. I'm going to write 21 down here, 21 bodies, and I'm going to calculate which one of these is going to be my limiting reagent. Okay, so let's just assume I've got 63 wheels, and I'm going to figure out how many bodies do I need to make wagons out of all of these wheels. Okay, so what I'm going to do is I'm going to take my conversion, right? We said it was 4 to 1. And I'm going to use that to convert to the number of bodies that I would need to use up all these wheels. Okay, and I'm going to see if I have enough. Okay, so what I'm going to do is I need to convert wheels to bodies, and I'm going to use my conversion factor. So if I'm going to do that, I can see that I want wheels to cancel, and I'm going to put bodies on top in order to do that. So I know my ratio is 1 to 4, right? I just take this one and flip it over, and then it becomes just a simple math equation of 63 divided by 4, right? My wheels cancel, and I've got 63 over 4. So if I do that on my calculator, this is not going to come out even, but it'll give me an idea. 15.75. So the idea is, if I'm going to use all of these wheels, I need 15.75 bodies in order to use it. And really, it would probably just be 15, meaning we would have 3 wheels left over. Okay. So then the question is, do I have enough bodies to put with the wheels to make wagons? Well, we started with 21, so yes, I do have enough of these. Okay, so that tells me that the wheels is not the limiting reagent, okay? Because if I want to use all of these wheels, I need this many bodies, which I do. Okay, so now let's figure out the rest of this. Let's calculate for bodies and figure out if the bodies is the limiting reagent. Okay, so let's do our conversion. So I'm going to convert this to wheels using my conversion factor. So now what I'm doing is I'm starting with the other one. I'm starting here. If I have 21 bodies, how many wheels do I need to use all of these? Okay, and then I'm going to convert this, right? I've set up my conversion factor so that this cancels out. And now I have 21 times 4 is the number of wheels I need to use up all of that reagent. Okay, so 21 times 4 is 84. Okay, so I can see that if I'm going to use 21 bodies, I need 84 wheels to do that. And I can see that, well, I actually don't have 84 wheels, right? We started with 63. So I'm limited in the number of wheels I have. The reagent that is going to limit the number of wagons that I can make in this example is the wheels. Okay, so now we've determined that wheels are the limiting reagent. Oops, limiting reagents. And so if wheels are the limiting reagent, that means we're going to have an excess of bodies. Wagon bodies, that is. Okay, so we figured out wheels is what's limiting me in this reaction. Bodies is going to be an excess, and then I could even figure out how much excess. Right, we know we have 60, I just erased it, we had 63 wheels. We know that that means we're going to use 15.75 bodies. We can't really use a fraction of a body. So really what this means is I'm only going to use 15 bodies. And we knew that we started with 21, so which means I'm going to have 6 bodies left over. Okay, so I'm going to use my wheels, but I'm going to have an excess of bodies when I'm making wagons. Okay, and I'm going to make 15, and 15 bodies implies that I'm going to make 15 wagons in this example. Okay, so that's an example of limiting reagents in a non-chemistry kind of way. So this, hopefully this is just kind of giving us an idea of how this process works. And the key is that I need a conversion factor to convert between the different reagents. Okay, so that's the new kind of component that we haven't seen before. Okay, so now that we've looked at that, let's go back to our example of combustion. Let's go back to our CH4 plus 2O2 yields CO2 plus 2H2O. Okay, so let's just make up a hypothetical scenario. Let's say I have 1.4 grams of methane and I have 2.1 grams of O2. Okay, this is how much methane I have, this is how much oxygen I have. I want to react them together, and I want to figure out which one is going to be limiting how much product I can make. Okay, and so in this example, I'm going to bring this down over here. What we're going to do is we're just going to calculate the amount we need with each reactant. Okay, so I move that down there. Okay, and we're going to calculate across. Okay, so let's begin with methane. What we want to do is we want to figure out if I have 1.4 grams of methane, how much oxygen do I need in order to use all of this up? Okay, so eventually where I want to get is I want to figure out I'm going to put it over here, grams of oxygen. How many grams of oxygen do I need to perfectly use up all of this methane? Okay, and again, we're going to use our conversion factor. Well, we know that we're going to want to convert to grams of O2. But in order to get from methane to O2, we have to use this ratio here, where for every mole of methane, I need 2 moles of O2. Right? That's my reagent ratio. But keep in mind, oh, I didn't actually write this. Mole for every 2 moles of oxygen, right? That's my ratio, is in moles. Well, the thing is I'm in grams here. So being in grams doesn't apply to the molar ratio because they're in different units. Okay? So what I need to do is I need to convert this to moles of methane. And once I'm in moles of methane, then I can convert it to moles of O2. And then once I've converted to moles of O2, then I can convert it to grams of O2. Okay, so let me put that out here. So we're going to have 3 conversion factors is what it's going to end up being, right? We need to convert from grams of methane to moles of methane. Then we need to convert to moles of O2. And then once we have moles of O2, we need to convert to grams of O2. Okay, so these are the 3 conversions we need to do in order to figure this out, okay? So let's do this one step at a time. First step, I need a conversion factor. How do I convert grams of a substance to moles of a substance? Well, we've talked about this in previous lessons. That is simply the molar mass, right? So I need to figure out the molar mass of methane in order to convert it into moles of methane, okay? And so I've already figured that out. I just need to add up 1 carbon plus 4 hydrogens, and that's going to give me 16.04. Let me check my notes. Yeah, 16.04 grams, right? And I'm in grams. I want to convert to moles, so I need moles up here. 1 mole, 16.04 grams per mole of methane. Okay, so this conversion unit is going to get me to moles. Now, I want to convert to O2, right? That's where this conversion factor comes in, right? I know that for every mole of methane that I have, I'm going to have 2 moles of O2, okay? So I'm converting to O2, so I want that one to be on the top. So 2 moles of O2 for every mole of methane. And that'll get me to moles of O2, and then my last step is grams of O2. Right, and we've said before, if I want to convert from moles to grams of a substance, I need the molar mass. Well, the molar mass of oxygen is, oh, it's actually 15.99 times 2. We can round that. Let's round that to 32. 32 grams for every mole of O2. Okay, so this is going to tell us how many grams of O2 that we need. Okay, so let's just do that. So we've got, so again, grams of methane is going to cancel out with grams here. Moles of methane is going to cancel with moles of methane. Moles of O2 is going to cancel with moles of O2. This is grams O2 up here. So I'm going to be left with grams of O2. So I've got 1.4 divided by 16.04 times 2 times 32. Okay, and that's going to give me this number. So let me get my calculator real quick and we'll figure that out. 1.4 divided by 16.04 times 2 times 32 is going to be 5.5 or 5.6 if I round grams of O2. Okay, so what does that tell me? What did we just figure out? Okay, we have 1.4 grams of methane. If I want to use all of this up in this reaction, we have calculated that I need 5.6 grams of O2. So then the question becomes, do I have enough oxygen to react with my methane? Well, I only have 2.1 grams of O2. So I can see that O2 then is my limiting reagent, right? I need 5.6 grams of it to react with my methane, but I don't have enough. I have less than half of that. So O2 is my limiting reagent. Okay, so which means I'm going to have an excess of methane. Okay, so we figured out O2 is my limiting reagent. Well, let's figure out how much methane are we going to have left over, right? We're going to use up all of our oxygen because it's the limiting reagent, and we're going to have some of this left over. So let's figure out how much of that we're going to use. So we can just do the same process where given this amount of O2, we can calculate how much methane we're going to use up, right? We're going to end with grams of methane. So let's just do that, right? We've got grams of O2, which means we need to convert to moles of O2. And then we're going to convert to moles of CO2. Oh, no, sorry, not CO2, methane, CH4. And then we're going to convert to grams of CH4. And that's going to give us how much we're going to use up, okay? So again, grams to moles, we're going to use our molar mass. So that's going to be, what did we say that was? 32 grams of O2 for every mole of O2. And then this one is just our stoichiometric ratio. So I'm converting to moles of methane, so that's going to go on top. I want moles of oxygen to cancel out. And then the last step is getting from moles of CH4 to grams of CH4, right? And I'm going to use my molar mass to do that, right? We already calculated it right here. So I know that that's going to be 16.04 grams of methane for every mole of methane that we have, right? And again, I double check, make sure things cancel out correctly, right? Grams of O2 cancels out here, moles of O2 cancels out there, moles of methane cancels out there, and I'm left with grams of methane, which is what I'm trying to convert to, okay? So then when I calculate my numbers, I'm gonna have 2.1 divided by 32 divided by 2 times 16.04. So let's calculate that out real quick. Okay, so I've got 2.1 divided by 32 divided by 2 times 16.04 is going to be 0.53 grams of methane. Okay. So, again, what did we figure out? If I want to use up all of this O2, 2.1 grams of it, I need 0.53 grams of methane, right? And we can definitely tell we've got plenty left over, right? We said that there's going to be an excess, and we've just demonstrated that here. We only need 0.53 grams to react with all the O2, and we've got almost triple that, right? And we could even figure out how much excess we have, right? If I take 1.4 grams and subtract away the 0.53, let me just do that real quick. 1.4 minus 0.53 leaves me 0.87 grams of methane left over. Okay, so that, in essence, is pretty much all I wanted to talk about for today. So that's the idea of limiting reagents, is that when we do chemical reactions, we do them with a certain amounts that are not precise. We're going to have leftovers of one, and one of them is going to be limiting. And so using this process, we can figure out which reagent is going to be limiting and which one's going to be in excess, right? We just do each one, convert them to moles, convert them to the other reagent, convert that to grams, and then we know how much mass in grams we need for each one. Okay, so that's limiting reagents. We'll do practice problems for this in class, but in the meantime, that finishes up this unit. So hope you guys got a lot out of it. I will see you in the next lessons.